Welcome everyone to the first of 4 scheduled webcasts of our TPM webinar series. I am Rose Kapsha from Tooling U-SME and your moderator for today's session. For over 90 years, Tooling U-SME has promoted the advancement of manufacturing by supporting new technology in industry and the development of its workforce to sustain manufacturing. We hope you enjoyed today's topic on the predictive maintenance. You can sign up for the remaining 3 topics on our website at learn.toolingu.com. You will notice on your screen there's a Q&A box where you can submit your questions or comments. We will have time at the end to answer questions you may have. A recording of today's session will be made available on our website at learn.toolingu.com. You will also see on your screen our facilitator's bio for today's session. At this time, I would like to introduce Drew Locker.
Thanks, Rose, and thank you all for joining us on this first of 4 webinars on the broad topic of what I describe as total productive maintenance, or TPM. I just want to, before we get into today's content, just want to talk about the 4 topics that we're going to be covering in this series. So we're all clear on what will be covered and not covered. So again, I use the umbrella term of total productive maintenance, or TPM, and that's made up of 4 components. One is preventative maintenance, kind of the old classic calendar tells you to go do some maintenance on equipment and we go do it. We will not be covering that in any of the 4 webinars. Now, it's kind of broad knowledge and awareness of what preventative maintenance is, so we chose not to include that in the series. Another of the 4 concepts that make up TPM is productive maintenance. And in that, we get into the design of equipment and try to improve mean time to failure, mean time to repair. We will not be covering that as well. That really gets into the nitty-gritties of specific designs of equipment. We're speaking to, I would expect, is a very broad, very diverse group of people attending. Another of the 4 is predictive maintenance, or condition-based maintenance. That is our topic today. And then the 4th component is operator-assisted or autonomous maintenance, which will be our topic in 2 weeks. So what will we cover in sessions 3 and 4, the 3rd and 4th webinars? The 3rd one, excuse me, is really how to prioritize your maintenance efforts. It can be very overwhelming, especially if you have a lot of equipment. Where do we start? So we're going to, in that 3rd webinar, cover two analytical tools: OEE, Overall Equipment Effectiveness, which maybe many of you are familiar with. But then I'm also going to cover an additional analytical tool that organizations with lots of equipment, dozens and dozens of equipment, have found helpful. Again, all just to try to help us focus on the biggest need. And then lastly, the 4th webinar will be on the culture. How do we break down the silos? We'll cover that a little bit with autonomous maintenance, but we'll get into it more heavily. Because really to get this going and sustaining over time, it requires some change, definitely change in roles, change in attitudes. So how do we create a culture that's really focused on equipment reliability? That'll be the topic of the 4th webinar. So hopefully that kind of explains what we're covering over the coming weeks. But today is predictive maintenance, leveraging data to anticipate failure. Also, at the end of this webinar, this topic isn't too complicated, to be honest. Probably about 30 minutes I'll need to cover the slides. But my hope is at the end, we don't just have Q&A, but maybe your people on the webinar are willing to share their experiences. I'm a firm believer you can learn probably more from each other than you can from me. So through the chat function, hopefully you can share what you're doing in this topic, maybe things that you found worked well, didn't work well, so others on the webinar can benefit from your experience. So hopefully we can get those conversations going at the end. But to start us off, let's just get some definitions out of the way. So what is predictive maintenance? So it's a strategy, very importantly uses data analysis, and in more recent years, machine learning to anticipate potential equipment failures and schedule maintenance in a proactive way. So kind of a different approach would be what would be called preventative maintenance, where we're doing maintenance tasks basically on a calendar. You know, if you think, and I always like to use automobiles as an example, you know, you got to change your oil every 3 months or 5,000 miles kind of thing. Whether or not it really needs it or not, we go do that. That's what the OEM, the automobile manufacturer, recommends. That's what we stick with. So that would be, you know, calendar-based maintenance. So it's not being done when the calendar dictates. With predictive maintenance, it's being performed when the conditions of the equipment dictate the need for it. Right? So again, pretty straightforward definition-wise, but why would we encourage organizations to do this? You'll get all the same benefits that you will from a classic traditional preventative maintenance program, right? We're being proactive, not reactive, so we should have reduced downtime. We can schedule it, so it's really not having a big impact on the business, as opposed to, you know, reactive maintenance when a machine breaks down. Arguably, it's more cost effective. There's, you know, you're going to still get cost savings, but as I'll mention in a moment, it's predictive maintenance is more cost effective. And obviously, if we're monitoring conditions very closely, we should improve safety. And if I use a car example, the car, you know, I need to take it in and get it inspected every couple of years nowadays. But if I pick up on conditions that's telling me that the automobile is not operating safely, I can, you know, better take it in sooner than later. So you get all the same benefits as you would with preventative maintenance. The real key is, because it's condition based, you're going to do it based on the change of conditions, rather than a fixed schedule. You could argue, and I think it's a safe argument to make, it's the most cost effective technique. Right? Not just doing it because the calendar tells you. So basically, another way of looking at it is you're optimizing the schedulings of maintenance related activities. And that's why most people would agree it's probably the most cost effective technique of all the ones that we have available to us on this topic. So what do we need to do it? And this is really very fundamental. And the way I'm going to go over in this webinar is kind of what modern approaches, new equipment designs. And then I'm going to frame it later as teaching an old dog new tricks. So, you know, how do we do it with existing equipment that maybe wasn't designed with this in mind? The underlying requirements are the same. And first and foremost is to identify the key conditions of a piece of equipment that are indicators of looming, you know, points of equipment failure that are coming in the maybe near term or intermediate term. So really understanding what the conditions are that we got to monitor. That's the key. Has always been that way, even before the advent of a lot of the bells and whistles that are coming on equipment these days, coming with equipment these days. Once we know what the conditions are, then we have to provide a means to monitor it, each condition. So we have to figure that out. And now gathering that information from the monitoring is one thing, but what we want to do is establish limits that would trigger a response, trigger the appropriate maintenance activity. So we need all three of these pieces in place, whether it's new equipment with all the bells and whistles and fancy automation and such, or older equipment. It's really no different in terms of the requirements. Now, particularly with even new equipment, but also older equipment, if we don't have the data to help us establish those limits that would trigger the maintenance activity, the appropriate maintenance activity, if we don't have that experience, that data, we have to create it. So I always tell folks, you know, start your PMs, your preventative maintenance program, until the requisite data has been collected and analyzed to tell you when, okay, here are kind of the limits for a condition that should be the trigger. So this is kind of what we had to do for decades before the availability of larger data sets, which I'll get into in a moment. But, PM doesn't go away necessarily. You're still going to need it maybe during the data collecting phase, and there might be elements of PM that you still have to do, even with a predictive maintenance program in place. Okay. So let's talk about newer equipment first. As the years have gone on, the OEMs, the original equipment manufacturers, have been doing more and more in this area, adding more sensors on equipment or machinery to continuously monitor particular conditions that can then, trigger a maintenance activity, or at least a decision or a signal to do the maintenance activity. Sometimes the equipment is designed where you can't even continue to operate it before the maintenance has been completed. Some it's just a signal. So if you think about automobiles, there's more electronics on cars these days than ever before, and it's monitoring all kinds of things. Most of the maintenance that needs to be done are on the electronics, is what friends of mine that do automobile maintenance tell me. So all kinds of sensors have been added to all kinds of equipment. Things monitoring temperatures, sound levels, the amount of vibration a machine or an area, a part of a machine is experiencing, lubricating characteristics, electrical conditions like current and voltage, and many others that it'd be a long list considering all the different types of equipment that's out there. So lots, again, bells and whistles. This is really based on a concept of model-based condition monitoring that was originally designed and used by NASA to monitor and detect developing faults in the space shuttle's main engine. But again, the concept has been around really for a long time, which I'll get into a bit. So model-based condition monitoring, that's kind of really the principle. And this allows for the automation or automated collection of data and analysis, not just enough to collect the data, but to do the analysis. And this whole model-based condition monitoring allows for continuous monitoring and warning about faults as they develop. So just a simple example, a spectral analysis on a motor's current and voltage signals can be continually monitored, ongoing, but it has to be compared to an established baseline. And that's the key to all of this. What is the established baseline? And then how far can we go adrift of that baseline before it triggers a maintenance activity, the appropriate maintenance activity. So, there's a lot of opportunity when you're buying new equipment to have these functions and capabilities in it. What I found from my experience, sometimes we're paying a lot of money for new equipment, and we kind of cut corners to try to save a little money. And we often cut corners on training, which I always suggest never do that. And another area I see companies sometimes cutting corners is some of the sensors and things, because maybe they're optional and the OEM offers them as an option. I always recommend don't take that as an option. Just do it. You won't regret it. Okay. So what OEMs are also doing is going beyond that machine, that single machine, and looking at all the machines that they have, similar machines or same machines that are out, in operation wherever they are around the world. And that gets into using the Internet of Things to collect larger data sets. And this is where the real machine learning's been coming into play here. Because with the larger data sets, we can accelerate the learning and figure out what those limits are to conditions, and use that to trigger the appropriate maintenance activities. So maybe you've experienced this. You have equipment that is logged in continually to the OEM, maybe some portal that they have, And it's gathering data on similar machines or the exact same machines that are all out in service, all out, in operation. And that helps. It gives larger data sets and really can accelerate the learning of the machine. The key or the concern I have there is in the old days, OEMs would, do a lot of testing of their equipment and life cycle testing. I get the sense sometimes, maybe someone has some experience or comments about this, that they're using the public, their customers, as the test case, and maybe not doing as much testing in-house as they used to do. Frankly, I hope I don't upset anyone, but that's how Microsoft operated for decades. They basically used the public to do their beta testing. They did alpha testing, but they used the public for beta testing. And there was an old rule: don't buy a new release from Microsoft. Wait a year. Don't buy it right away. I do get the sense that some of the new equipment, that some of that's going on. As sometimes I'm involved with the company and the decision making of new equipment, and I ask lots and lots of questions of the OEM, and sometimes I get a sense that I think they haven't done as much testing as they have in the past or should have done, and they're using the users as the test database, which I guess is okay. Just be aware of it as you get into it. There may be some surprises. So that's where the Internet of Things comes in, giving us be able to collect very quickly larger data sets and get to defining what the requirements are or the limits are to each condition. So that's the new equipment. What about old equipment? Teaching an old dog new tricks. It may be possible to add sensors to old equipment that continuously monitor the particular conditions. Possible. It's always possible, at least from my experience, to be able to use devices to periodically monitor particular conditions. And some of the pictures here on the slide are examples of that. So like a vibration analyzer, handheld device that a maintenance person or an operator, depending on how you want to do it, would monitor the amount of vibration a machine or a part of a machine, a component of a machine is experiencing. Now, you have to go about this the proper way. We have set points that we take put the probes on. So we're always very consistent there, measuring from the same points. And very importantly, as I'll mention later, we have to have a baseline. What is acceptable vibration, what is not acceptable vibration. But you would do this periodically. How frequently, I do not know. But you can do it periodically rather than continuously. Yes, it would require some investment in some equipment, like the vibration analyzer itself, but often it's worth it, especially if you have a large number of equipment. Sometimes with the equipment too, I always suggest to organizations, if it's starting to look a little cost prohibitive to buy some of these devices, is to maybe you can share with your neighbors if you're in an industrial park or something, or share with other locations within your company. But it could be something simple like a temperature sensitive label. It doesn't have to be in a digital device. These are just stick-ons, and you put it right. Got to figure the right location for it, but you put it on the motor or any device, and it changes color based on not color, but the label will change based on the temperature that it's experiencing. Now, what we would do here, I don't know if you can see my cursor, but we would draw a vertical line kind of where the limit would be. And this is pretty simple. This could be a maintenance person checking it at some predefined frequency. It could be an operator because it's so simple. And drawing the line so we know what the trigger is to again trigger an appropriate maintenance activity. Say it's a motor. It's getting warm, but it's getting it's hitting that limit. Or you can get an infrared scanner. It's again handheld, portable. Some things you just can't put temperature sensitive labels on, but you can use an infrared scanner. We use this a lot for like electrical panels. Again, you have to have a baseline, and then you kind of compare it to the current readings, and you can see like hot spots of contacts in an electrical panel, for example. Wear particle analysis, we're taking, say, lubricant and looking for little particles in there that would indicate wearing of usually turn parts, a shaft, a rotor. And you could take this outside to a lab and do a very thorough analysis. But there's even like very simple little, it's like a filter material, and you just put drops onto it, and you'll see metal shavings and things pretty clearly, and say, okay, we think we got a problem brewing here. And then we can trigger the appropriate maintenance activity before we get into a big problem and a catastrophic failure. And this is something you would do definitely periodically. Again, what frequency you have to decide. What's the right frequency? And you'll hear me say this later. Experience is data. So usually getting the right people in the room talking through this, you can say, we should do this every month, or maybe every quarter is enough. You'll probably be pretty darn close, just drawing on the experiences of the operators and your maintenance folks. And these are all periodic checks, not continual checks. It could be simple things like air ribbons. We were tying these on years ago. And maybe when the air is flowing from a fan, that's maybe cooling a part of the equipment, and we were accustomed to seeing it at a 45-degree angle. We know the fan is operating, the airflow is going fine. And we could just tell operators, hey, check that at some frequency. And if you see it dropping below 45 degrees, let someone know. That might be an indication the fan's not operating properly, or maybe some filters are clogging and not allowing the adequate airflow. So it could be that. And back to handheld meters for electrical, conditions, current meters. Again, you need baselines. What should it be drawing current-wise? What is it not? Or what is it doing now? And compare the two. And same thing with sound meters. Sound meters are excellent, but you have to kind of know what is acceptable. So, I'm kind of old school, been at this for a long time. So air ribbons, done that countless times. If I go back a slide, vibration analysis. My first time I did something with that was I had these coil winders. We were making motors, fractional horsepower motors that would go into appliances, your refrigerators and such. And my coil winders, if they got a little out of level, could create some big problems very quickly. And my maintenance guys are always saying, this one's on, we're getting these too late. So, what we did is we had a sealed container of water, and a certain amount of water was in it. And we just kind of drew lines around it, like a band of lines around it. And just ask the operators, hey, if you see the water splashing beyond these bands, call the maintenance guys. Call a maintenance technician before it becomes a big problem. Because when those things got out of unlevel, it could create some big problems very quickly. And it was very simple to do, and we fixed it to the top of the machine so it wouldn't fall off or anything. But that's just, I thought it was clever. That's what we came up with at that time, and I thought that was pretty clever. So a little creativity, you can come up with your own means of monitoring. The key is to really understand or identify the conditions themselves. Then with a little creativity, we can either get online, find some sensors, or come up with something more clever. There's some other things we can check too. Some measurable kind of things like dimensional measurements. So like a hydraulic press. We know we're running into trouble if the running clearances are changing, or it's getting out of parallelism, or the lift clearances are changing enough. That would indicate maybe some bearing wear is happening on the various bearings on a hydraulic press. And again, a maintenance person could check this at some frequency, maybe an operator if it's easy to do. Again, we have to, that's what we'll get into in 2 weeks, operator assisted maintenance. But whoever does it, we got to be clear on what's acceptable versus not acceptable and have some limits. And say, okay, if it goes beyond this, we've got some significant bearing wear that we need to address, and we'll go schedule that meeting at maintenance at a convenient time. Another example would be like spindle wear on milling machines, the amount of adjustment needed to tram the head in. I was doing this back in the 80s and said, okay, it should be this amount, torque. If you've got to go over that, just stop, call the maintenance guys and let them, check the spindle head and probably replace it. I think we even had extra spindles so we could swap them out. We were doing very high tolerance parts, very tight tolerance, I should say, parts, and this could create some rejects, some scrap very quickly. But it was all around the amount, really torque we were putting on to tram the head in. More recently, I worked with a petrochemical company, and they by regulation have to check like pipelines. So often they got to check pipelines to see where it's starting to wear thin and could perhaps have a rupture of the pipeline. Well, before they would have to cut out the insulation around the pipeline. These are out in the elements, and they had to stop as soon as they cut that insulation out. They had to stop the flow through the pipeline, and then they would do their checks. They did some research a few years ago and found, I think it's radiography type technology. They didn't have to cut out the insulation so the pipeline could keep flowing with the contents, and they would get their accurate reading. So it was zeroed, forget non-destructive at any level. It was also didn't disrupt production, and is allowing them to do much more inspection of the pipelines to see where they're starting to have issues that they'll have to stop, cut it out, and replace it. So that's anyway. I won't tell you how much money that saved them, but it's ridiculous. I mean, millions of dollars. And I know for a fact the regulators that come in that check on making sure they're doing what they're supposed to be doing are just blown away. They're going well beyond what is required by typical regulations in terms of their pipeline inspections. So here's an example that has nothing to do with manufacturing that I'll draw on, but an important one. So if I have conditions and I got to establish limits to trigger the appropriate maintenance activities, how do I set the limits? Experience might tell you, if you go beyond this amount, this level, you're going to expect problems. But we can also use statistics. So I have used, and I encourage companies to consider using statistical process control charts on particular features, particular conditions, to monitor the amount of variation they're experiencing. And if they go beyond a control limit, still not failing, it tells that would trigger the appropriate maintenance activity. And we would do that at a convenient time. And one of the earliest applications of this was in the mid-'80s, and my wife, who ran a radiation oncology department, had treatment machines. And she was, asking me, she saw me working on a total productive maintenance program with a company. And she says, can you explain this to me? And I explained it to her. And she, a couple of days later, she came back and said, can I do this on my treatment equipment? I'm like, sure, let's talk it through. What was great is that she and her technicians understood the conditions that they had to monitor, informally. And they would know, okay, this machine's starting to get a little out of whack. We better start calling in the technicians, the service providers. They were outside service providers. Usually OEM that they bought the equipment from would offer the service. Now, to put this in a context, they would run the equipment until failure. That's still very typical today. Still very, very typical today. And, what they did is we set up, I think it was about 4 control charts. And the frequency was at least like maybe 3 times a day, in the morning, in the afternoon, and I think there was one in the middle. They would take their data points, their measurements, and put them on the chart. And we had control limits on the chart. And if it exceeded the control limit, they knew to call the service provider, and that would come in. And it was remarkable. We actually measured OEE, overall equipment effectiveness, before and after. And their machines went up into the 90s, 90%, in terms of uptime, which was unheard of in that industry at that time, and probably still today. So think about, what conditions vary over time, where of any part, calibration over time. That was a biggie with the radiation treatment machines, was the calibration. But there could be other conditions too. And if most do vary over time, maybe an SPC chart can help us, give us that trigger, give us that trigger to that we're always in search of. So something to think about. I think it still is applicable today. I don't know this for a fact, but I would assume that there's SPC charts on all this data that the machines are gathering on their own. The newer machines are gathering on their own some form of chart. So they're monitoring trends to see, to send that signal that maintenance is probably required. So something to think about there. It helped me. So as I said, there's not a lot, to grasp on this concept at all, this approach. So I'd like to open it up to you all. What have you been doing in the chat? You can note what you've done in this area, what you found worked, didn't work, and you can be specific about your equipment. Or if you just have some general questions. So we've got plenty of time, good 15 minutes or so for sharing as well as answering questions. And if I can't answer it, maybe someone on the on the webinar can. Excuse me. So no questions are coming in. There has to be some sort of, or even, again, not questions, but has anyone, please, in the chat, has anyone been applying predictive maintenance? Maybe you called it something else. Maybe you called it condition-based maintenance. Any examples, and what were your experiences? Positive or negative experiences. We can learn from both. So aviation, high use of predictive mix. So we found good results of oil samples in jet engines. I would hope so. When I had a real job in the 80s with General Electric, we made jet engines. So I would hope so. Aaron, could you expand a little bit? The sample, the testing techniques of the samples, that's something you guys do internally? Do you have to use an outside lab, or do you have your own lab? All right, we have another one coming in, but what I find amazing is when the potential costs of failure are so great, organizations tend to do the right thing. So aviation being just one example of that. Here's one from Pamela. Fellow participants, if you were preparing students in an industrial maintenance technology program at a two-year tech school, what SPS and other techniques would you recommend as part of the curriculum? SPS? Pamela, what is SPS? I don't want to assume. Now we're getting some things. So just back to the oil analysis from Aaron, each bearing has different metal content, brilliant. The metal particles in the oil indicated which bearing was fouling. Beautiful. As a frequent flyer, I'm glad to hear this example, Aaron. All right, how about William McClung? Once you add all the instruments, how to prevent the data from overwhelming your operators? That's a great question. So if it's automated, it's not so bad. I mean, think about your car, right? You've got this dashboard with all kinds of information. So we can get accustomed to it, right? Especially if we set it up. Again, I'm thinking more automated, where it's continually monitoring. You can have lights put on when it hits a certain level, again, that trigger. So it's like your trouble light on a car. So you don't have to look at all of the instruments. You're just looking at the ones that are starting to fault. And that goes to the point of you got to have the limits defined. Another thing too, if it's not automatically collected and you're asking operators to go check these devices, just pick a reasonable, frequency, so it's not overwhelming. So, because I agree, it can be overwhelming. We'll talk more about that in 2 weeks when we go over operator-assisted or autonomous maintenance. We're going to make sure what we're asking the operators to do is not overwhelming. They have the time to do it. Or spread the responsibility around as well. Maybe different people do different parts of it. But if it's automated, it's, they don't have to go anywhere. The information is being presented to them. My suggestion is to kind of do the trouble light approach. So they're, some sort of red, green. Don't worry about the green, worry about anything that goes up with red. And hopefully that kind of winnows down the information flow coming to the operator. I don't know if that helps William or not, but that was what first came to mind with your question. Let's see. Oops. Oh, so SPC you meant, Pamela. Okay, thank you, not SPS. So does anyone have any answer to Pamela's questions? If you're preparing students in an industrial maintenance technology program at a 2-year tech school, what statistical process control and other techniques would you recommend as part of that curriculum? If anyone has some suggestions for Pamela, please type that into the chat. Let's see who else we got here. Adrienne Temple. When I was in manufacturing, I assume that means you're not in there anymore, I found out that some of our technicians were not capturing the actual RF of code. So they were capturing what they did as part of the routine maintenance when they pulled that piece of maintenance. So that's a great piece of learning for people. We got to distinguish problem from cause or, failure. Otherwise, the database won't give us the information that we need. Now, there's some things that maybe we can do to help minimize the kind of error in the data gathering. Maybe pull down menus and you have to pick a certain one, that kind of thing. So in the example that Adrienne provides, she said, replace the traverse guide while the winder was pulled. That's not telling us what the fault was it? Or the condition was. So that's great learning to share with everyone, Adrienne. Thank you very much for that. It's no different with any data gathering system, right? Quality related data. I've encountered that many times where they confuse problem for cause or the action they took to solve it, and therefore we don't have good data. So please heed Adrienne's example there and suggestion. Jesse, on new CNC lathes, we test a failure on clean out PMs. At that time, we do a scheduled PM. We test the failure on clean out PMs. At that time, we do a scheduled PM. That's an example. I see what you're saying. So the condition gets to a point where, okay, we got to schedule the PM. And no, it doesn't sound like there's fancy sensors and things, Jesse, right? I don't think there's anything clever there, or not clever, but technical there. Excellent. We got a lot of examples here. Greg says, we're actually looking to start our oil testing and transformer oil testing maintenance program. Excellent. How would you go about finding vendors to do this testing short of a Google search? I don't know if you have neighbors that maybe are doing this. Even if you do a Google search, always ask for, recommendations or references, so you know. But most of the labs that do this are pretty, reputable. But if anyone has a suggestion for Greg on how else, I would always talk to my neighbors first. Even if they have very different equipment, is anyone doing this? Are you happy with their service? I don't know if there's a Yelp for these kind of things you can look at online. So, but you bring up a good point. Always want to be careful with who you're dealing with. But most of the named labs out there that provide these services, are reputable. But definitely beware. Also from William, yes, call these lights stop lights. So you guys put some lights on the machines and stop. All right, Paul, okay, how do I get my arms around where to start monitoring on automated equipment, which has many servos? Linear slides, pneumatic components, grippers, etc., all could potentially fall or wear. Thoughts on how to get started. So Paul, data, this is something we'll talk about more in the fourth webinar. But to answer your question now is data. So what has history told us where the failures have been? So short of data, experience, is data, short of classical numbers. So just sitting with the maintenance folks, operators, whoever's been around that equipment for any length of time, just getting them to recall past failures, what it was. Oh, we never had problems with the linear slides, but man, those grippers, okay, let's start there. Or you could gather data going forward, like OEE type data, overall equipment effectiveness data, to capture what's going down. But that could take some time. I don't know how often things are breaking down on this equipment you're referring to. If it's very new equipment, I would just start with your OEM's recommendations, the original equipment manufacturer's recommendations. But short of that, if you've had the equipment for a while, just draw on the collective experience of anyone that's been around it, the operators, maintenance folks, anyone. Sometimes I've had the buyers be able to provide valuable input. Well, they're always asking me to buy this part. And I'll be like, okay, let's do something with that part. I don't know if that was helpful, Paul, or not. Okay, and back, Bill, start with your lubrication vendor for oil testing. Oh, that's a great suggestion. So who are you getting the oil from, right? And maybe they have some recommendations. Or maybe they offer it. I don't know. William, does the vendor sometimes offer the service? Do you know? OEMs offer various services, but I never thought of the lubricant vendor offering testing services. But why not? Do you know, William? Like, would a mobile actually offer the service of doing the lubricant testing? Never hurts to ask, probably, right? Thank you for sharing, folks. That was good. Any other questions? Any other sharing you want to do? I think I hit them all. Did I miss anyone? Mobile does do it. So there you go. Or if you get it from someone else, maybe ask your lubricant vendor, hey, do you do this kind of testing? And what does it take? There's a relationship there, right? You're buying the material from them. So I would like to think they're willing to help you out. It's in their best interest, I would think too, William, right? You would replace the oil maybe more frequently. Any other questions or examples, or just general information you want to share on this subject? I thought that went well. Some good ones. Okay, then we will wrap up. So, Rose, anything you want to say before we call it a webinar? Are you still there, Rose? Or Angela?